Welcome. My name is Wanuzo Cosmas. I'm going to present a review of linear regression computation machine learning paper. So I'm going to take you through the introduction, the simple linear regression, multiple linear regression, the polynomial linear regression, the least square method, and the two tests on machine learning on linear regression models, which are the F-test and the T-test, and the applications of linear regression in machine translation, which aligns with the research topic we are currently working on. For introduction, linear regression is a statistical machine learning algorithm used to predict the linear relationship between one or two continuous variables. The main objective of the algorithm is to establish if there is a relationship between variables and determine how reliable that relationship is. Like you see, we always have our dependent variable, which is the variable we intend to predict on the y-axis usually, and then the independent ones on the x-axis. Then we can use a linear function like y is equal to mx plus c, the equation of a straight line. Then we have our data points, and then the baseline of it, which is the entire the core of linear regression. With the baseline of it, we can establish that there is a positive relationship between the independent and the dependent variables, as we are going to see. In simple linear regression, we have a single dependent variable. In this case, we have the dependent variable is salary, and it's a single independent variable. Since the dependent is salary, so the independent is years of experience, so it's the x, and then the y is the salary, which is the dependent, so it's always a single independent variable, where our beta node is the y-intercept, or how much the salary will be when there is 0 years of experience, and then b1 is the coefficient, or how much salary increases per unit year of experience, and then E is our error term, which we aim to minimize using linear regression. Multiple linear regression. In multiple linear regression, we have more than one independent variables. As you can see, we have additional, we have porosity and brittleness as the dependent, and then the gas production as the dependent, and then the independents, we have more than one porosity and brittleness. So we end up forming some sort of 3D structure where we have a plane instead of just a single straight line. So again, y is our dependent, then this is the y-intercept, which is the value of y just in case porosity and brittleness are 0. Yeah, and then E is our term we intend to minimize using linear regression. Then the next thing is polynomial regression. Here we analyze the relationship to the nth degree, the relationship between independent and dependent variable to the nth degree polynomial. As we can see, instead we have to square to a certain degree compared to just calculating a simple independent factor. So we have to square the independent variables to a certain degree. And then the least square method, which is the foundation of linear regression, which is used to determine the baseline of it. And here we have to use residual distances, which are the distances from the data points to the baseline of fit. In this case, as we can see, we have our line of fit. Then from this line of fit to the vertical distance from the data point to the line of fit, which is the residual distance, we have to square these distances and sum them up. Always find the minimum distance, the distance where this error term is as small as possible. So we use the least square method, whereby we start with a single. We can start with the first line, whereby we can find the average of y, which is our dependent variable, which might be something like here. Then you draw that line, and then you keep on changing that line until, while calculating the residual distances, until you find the line with the most minimum distance. One of the tricks that I used is finding the average of y, which is our dependent, and the average of x. Then you have our centroid, which is a point here in the middle. So we keep on drawing lines that pass through the centroid to make sure that we have as many lines as possible until we find the baseline of it, which is the line which minimizes the distance from the observed response to the predicted value. Yeah. So linear regression tests are described in form of two tests. One of them is the F test, which tells us, just in case we have two data sets, the F test helps us to understand the variation in the standard deviations of the two data sets. So you have to understand how the two data sets vary in terms of the standard deviation, so that we know which of this data set is fit to describe the linear relationship between two variables. And then we have the t-test, which helps us to determine if two means or averages are reliably different from each other. Yeah. So then applications of linear regression in machine translation, which is our research topic. Linear regression can be used in determining whether a certain text is part of speech. Maybe if we want to understand, like, is certain speech hate speech, so we can use linear regression to know if a certain text or phrase in a corpus is part of speech. So it's used in part of speech tagging post, and then it can also be used in shallow parsing, where we have to understand that in a particular sentence, what constitutes a noun, what constitutes a verb, what constitutes an adjective. So we can use linear regression and regression methods to know such meaningful insights. Yeah, these are the references I used for some of the content I've been presenting. So thank you for listening.